Everyone, this is Ryan DeGregorio, one of Wyoming Stargazing's program leaders. Thanks for joining me, and welcome to Mind Bending Astronomy. In every episode, we'll share with you a mind-bending fact about astronomy. Last time, we talked about the Fermi paradox, which deals with the question, why haven't we encountered any alien life yet? Well, today, we're going to be exploring other worlds, extrasolar planets, or exoplanets. So in today's episode, we're going to be talking about the three methods used to find exoplanets. The first is probably the easiest to understand. It's something called the transit method, and what it involves is measuring a star's decrease in brightness. As a planet, another planet, orbits around its host star, it passes in front of it, and a shadow is cast onto the face of its host star. But we don't necessarily directly view that transit occurring. We don't see the planet passing in front of the star. All we do is look for a dip in the star's brightness, because it does decrease a little bit when the planet passes in front of it. The second way is a little more complicated. It's called the Doppler Method, and it uses the Doppler effect, but not in terms of sound, in terms of light. What we do is we can look at a star, and what happens to the light that we receive is it sometimes gets redshifted and sometimes it gets blue shifted. When it's redshifted, that means the star is moving a little bit away from us, and when it's blue shifted, that means it's moving toward us. So the light is getting longer in its wavelength and getting shorter based on how the star is moving. And you might ask, why is the star moving? Aren't we looking for the planet? Well, yes, the star does move a little bit when the planet goes around. Because of gravitational interaction, the planet is pulling on its host star just a little bit to make it wobble. And we measure that wobble using the Doppler effect. The third, and probably the most complicated of all three, is gravitational lensing method. And in lensing, we have the star with the planet nearby and then a very distant star much farther away. The host star with the planet bends the light of the distant star, and it comes around. And we notice this bending effect because the star that we're looking at is sitting in the middle. We detect the planet orbiting the star because the light is bent a little bit more than it would be if the star was just by itself. So that is your third way of detecting exoplanets. And we found several hundred planets outside of our solar system, and perhaps there may be one with life just like ours. Thanks for joining me, and we'll see you next time.